already know me, except for the new people in RCOS. My name is LiB3, and I'm here presenting my company, but really my company started out as an RCOS project, so I'll go through all of that. So in RCOS, I was the lead mentor for a few semesters, and I've been a member of RCOS or participating in projects since sometime sophomore year, I think, first semester, and then every summer since then. I'm now not at RPI. It's kind of a long story, but I have like a couple classes to take, but I'm just not doing them now. At some point, I'll get my degree. But for the time being, I'm doing my company and another company I work at full time. But at RCOS, I did a lot of projects, and some of them got finished, sort of. They were a lot of fun, and I learned a lot. And LiB3 was started 2 years ago as an RCOS project, but not really. So what I was doing was something called embedded hardware with the MSP430, and this was a set of tutorials for how to use this processor that TI made. At the time, it was pretty much the cheapest embedded hardware development kit you could get. It was $4.30, and it was pretty similar to a basic Arduino. And it could be used for a lot of different things, especially in academics. The goal of this project was to sort of make a lab manual of projects. And then that summer, I ended up founding LiB3, which is an online retail business focusing on open source hardware. This is what it was. It's not that anymore. Profit comes from discounts and volume manufacturing not available to individuals. Basically, I was going the whole approach of make a product and sell it and make money from selling the product. And this product was something that started out as one of those tutorials for that MSP430 lab manual. So it was basically an intelligent lighting controller. It had an MSP430 on it, obviously, a microphone, push buttons, sensors. It could talk with Bluetooth to your phone, and it could control a bunch of RGB LEDs. It was really simple. I did a Kickstarter. I learned a lot about actually trying to sell a product. And that brings me to open source hardware. This was obviously open source hardware, so it was done as part of RCOS. Open source hardware is a kind of complex thing. I mean, in its most simple sense, it's the same idea as open source software. Make something, give it away for free, and make it such that it will continue to persist as a free thing. But it's pretty tricky when you start looking at patent law and the fact that copyright doesn't apply to hardware and all the different ways you have to protect the intellectual property. So to sort of guide this, there's this document called the Open Source Hardware Statement of Principles and Definitions, version 1.0. They've never made another version since. Free redistribution. Obviously attribution, so if someone does make a new thing based off of your product, they still need to say that you were the original, or you made part of it. And then the real interesting ones are technology neutrality. So you can say that I made this product, my design uses these certain chips by these manufacturers, but you can't say that it has to use those chips. So it has to be freely able to be ported to other pieces of hardware and adapted for use on different platforms. And then this one's actually really important. No discrimination against fields of endeavor. What that means is if I make, let's say, some sort of environmental sensor device, something I'll stick outside and it will measure the rain and temperature and put it on the internet. And the military wants to use it for espionage. I can't say that they're not allowed to. It has to be freely available for everyone. So I can't say that my device can't be used by the military or can't be used by terrorists or anyone else. I mean, terrorists is actually a thing that you probably could say, because it's like federal law, how supersede copyright and stuff. But it has to be completely open. So in order to do that, you obviously have to have some sort of license. And open source software licenses control distribution of source code and documents, and that's all copyright law. But open source hardware focuses more on manufacturing and use, which is patent law. So most of the time you use some sort of adapted open source software license. And usually it ends up being something like an adapted BSD or MIT license. So that's pretty open and pretty permissive in terms of it being reused in derivative works and in commercial products. Open Cores, which is the currently largest open source hardware community, they basically make open IP cores for FPGAs. So various different pieces of hardware that could be used within an FPGA-based project. They use a version of the LGPL. But then once you actually have open source hardware, how do you do anything with it? If you're giving it away for free, obviously your business model needs to be a little different. So there's various different ways you can do that. One is to have services. Things like you're doing custom designs for companies, or you'll take your piece of open source hardware and adapt it for other people's use for free. You can do manufacturing of it. You can manufacture proprietary hardware that has large open source hardware components, and that's actually seen really commonly. There's a lot of different modules that are open source hardware, especially things that started out as like an IBM Shield. You can dual license hardware. You can have a proprietary license, and then you can also have an open source license, but the hardware is the same, and maybe there's a different software stack that gets used with. And then you can make proprietary tools exclusively for open source hardware development. And then oftentimes you see things like partnerships between manufacturing and distribution, where you'll have a company that does open source hardware that partners with a manufacturing company to deal with all the actual sales. And you can also, this is occasionally seen, it's not usually very effective, but you can essentially fundraise for open source projects to have more complete documentation. And that's sort of like the whole tip jar model. It's not very good at growing real fast, but it can, if it's essentially your hobby, provide a little bit of money to support continuing development. So what Arduino does is basically sells their expertise in custom services. So they make the Arduino, but then they also do a lot of design consulting with companies that use Arduino, and that's where they make a lot of their revenue. They sell the hardware, and they make some money off of that, but not a lot. But ultimately, since Arduino is open source and anyone can make their own version of it, what they need to do is continually keep innovating. So keep cranking out new versions every year and make the new versions better than the old versions. That way, the open source clones are the previous version of it. And that's what I had started out doing. The whole idea of I'd make lots of open source hardware things and sell them. It's actually really hard. And it's not the open source hardware that's hard, it's dealing with manufacturing and supply chains and all of the logistics of actually selling the product. So what we do now is design consulting and manufacturing. I didn't spell manufacturing right, but and what we're basically doing is developing services that are used by open source hardware and just small companies in general, sort of make this whole process a lot easier. And the kinds of design consulting we do are either complete projects, and we've done at least 10 over the past year, and design for manufacturability, basically looking at someone's design and making suggestions for alterations to make it so it's more easily manufacturable on a larger scale. The manufacturing we do is PCB assembly, and we'll do complete turnkey assembly, where someone will send us a design and then they'll receive a completed working program and circuit board tab. So this is what our space looked like a little over a year ago, around a year ago. We rented this big warehouse and bought a pick and place machine. That's that big thing there, which is essentially a big robotic machine for placing small components really, really fast on circuit boards. Obviously, this wasn't exactly an ideal manufacturing space. It was literally the second floor of a wooden warehouse. So we was slowly building out. This was a couple months later. This was a little bit after that. You can see we actually have a floor. And this is where we are now. We actually have built this manufacturing facility inside the warehouse. And this is a couple months old. We actually have a lot more equipment now. We just got X-ray inspection and some other software equipment in addition to the place machines inspection equipment. And we're actually most likely moving sometime relatively soon. We're in negotiations with another company for a partnership where we'll be expanding drastically, opening up a facility somewhere between 5 and 10 times the size of this one in the next 2 or 3 months, actually. So it's really exciting, and hopefully it won't fall through. We'll see. But, yeah. Anyway, the two branches of what we do are PCB Center, which is our manufacturing, and LiB3, which is our design consulting. And we want to help with RCOS projects. So if you're doing a project that has hardware as a part of it, whether it's circuit design or some sort of mechanical assembly or whatever, and want DFM advice, send me an email. We can also actually do PCB assembly and either show you how to do it, and you can do it yourself, or work with you through the process, or we'll just do it as a turnkey thing. And then probably other stuff too. I put these slides together about 10 minutes before I started presenting, so I didn't exactly come up with a full list. But if you think that LiB3 could help with your project, let me know. So thanks for having me. Thanks to RCOS in general for the treat me today. Does anyone have any questions?
Yeah, I was wondering if you had to file like defense and patents for open source hardware. I don't know if that's a thing that.
Well, most of what we do, since we're primarily doing, I guess we need in general for open source hardware, it's certainly something that does get done. But ultimately, a patent, if it's already in public domain or it's already published, you can't patent it. So as long as you properly document everything and release it under an appropriate license, you can't. No one else can patent it either because you've already released it. The same way if you were to release a white paper or something that sort of replaces the patent and prevents someone else from patenting. Since the whole goal is sharing it anyway, there's no reason to worry about patenting as long as you're publishing.
Is anyone interested in open hardware project this semester? Raise your hand if you are. So a couple of you, good. I have no idea if this is any good or not, but I had in my office received a bunch of Grove starter kits plus from Intel or something like that. Anything to you? Some sort of hardware stuff to play with. So if you're interested in that, I had a few folks email me at the end of last semester, but there's some hardware kits, whatever that means, in my office. I have no idea if they're useful, but it might be something to check out. You said you had nothing else? No, we're good. So maybe just one or two closing remarks before we disappear here. Definitely, obviously, thank you for your interest in RCOS. There's, again, my role being largely administrative paperwork stuff. Is anyone planning to get paid for RCOS this semester, but you've never been paid by RPI before? So you're going to be brand new to the payroll at RPI. Yes, a couple of you, okay. There is a separate packet of additional forms that you get to fill out. Congratulations. They're I-9, they're federal, state government forms, blah, blah, blah. So definitely watch your email for that. I'll send it to the whole group, sorry everyone else. But watch for that, and they'll be available this week as well. Thank you all. Have a good week.